Do you know that volatile organic compounds are 2 to 5 times higher indoors than outdoors? How can we solve this?
Solving this issue takes collective effort.
This is why we are introducing Hydrogaria.
A coconut oil-based strawberry perfume low in VOC.
Hydrogaria, profiling volatile organic compounds through GCMS testing in perfumes using alternatives Fregaria ananasa, strawberry hydrosol, and Cocos nocifero coconut oil.
I am Riangel Francesca Hermoso.
I am John Ezekiel Buere.
My name is Raven John Asaire.
My name is Vana Claudette Karin.
I am Margia Constante.
I am Kay Chelsea Malyari.
What are VOCs? Volatile organic compounds or gas emissions from different products, solid and liquid. This group of chemicals both vaporizes in the air and dissolves in water easily at room temperature. But Buena, Kay, why is this a problem?
One of the many causes of insufficient indoor air quality is volatile organic compound, or known as VOC, and these VOCs can commonly be found in perfumes.
Exposure to VOC chemicals can irritate the eyes, nose, and throat. It can also cause difficulty in breathing and nausea, and can damage the central nervous system and other organs.
This is why we ought to find a solution by using the strawberry hydrosol and the coconut oil as main components and alternatives to VOCs. Strawberries have only 19 kVCs and coconuts have 15. That's according to a study from the Philippine Journal of Science from DOST.
Research study aims to identify and analyze the presence and amount of particular compounds and potential contaminants of the perfume sample Hydrogaria through GCMS compound analysis.
This study is a way of showing awareness and opening more doors for VOC related studies as they are being used daily. This study addresses the current IAQ issues caused by VOC by finding and testing potential alternative main ingredients.
For the experimentation, oil extraction and the actual experimentation will be done at different institutions. The LaSalle University Binyan, the LaSalle University Dasmariñas, and DOST ITDI Industrial Chemical Section CED Taguig. The formula for perfume making is formulated by a qualified scientist. The protocol for the GCMS analysis will be according to the GCMS DLSUL in-house testing standard and parameters.
A Clevenger apparatus is used for strawberry hydrosol extraction, consisting of three main parts: a round bottom flask, a separator, and a condenser. Coconut oil was sourced from craftology, recommended by a qualified scientist, while the emulsifier is from Asteria Apothecary, an FDA-approved supplier. Strawberries are freshly picked from Clean Strawberry Farm. Fragrance note oils will come from Clean Pro Solutions, confirmed organic and approved by the DTI Philippines. Glass perfume bottles and packaging from Glasspack Philippines are eco-friendly and registered with DTI and BIR. GCMS testing will be performed using an Agilent 8890 GC system coupled with a 5977B MSB provided by DLSU Binyan.
Procedures were based on Agritech TNAO and FRI Dehradun 2011. Surplus strawberries 1 kilogram were sourced from Queen Strawberry Farm. Hydrosol extraction took place at DOST ITDI Industrial Chemicals Section CED. Strawberries were cubed, excluding leaves, and frozen overnight at negative 18 degrees Celsius. Boiling in water was used for extraction, utilizing various heating methods. The Clevenger system was used for distillation. Distillate, containing steam and oil vapor, was separated. Distillates were suitable due to low oil content in the strawberry. In the end, 500 ml of the hydrosol was separated.
Formulated by a qualified scientist, the procedure was executed at the LaSalle University Dasmariñas, with sanitations using antimicrobial blue light for 30 ml bottles, 36 drops of mixture 1, 18 drops of mixture 3, and 6 drops of mixture 2 was used alongside 180 drops of coconut oil for 3% dilution, plus 60 drops of polysorbate 20 and 600 ml of strawberry hydrosol. Bottles, beakers, TD pipettes, and fragrance strips were prepared, ensuring immediate placement of the strawberry extract to prevent losses. Samples were stored in frosted glass bottles from Glasspack Philippines, sealed with screw cap, and stored at 12 to 22 degrees Celsius. 330 ml samples will be prepared.
Compound level testing was conducted at DLSU Binyan. Perfume samples were transferred to a vial and transported to DLSU Chromatography Laboratory. Sample preparation involved using a microcentrifuge tube, micropipette, pipette tips, and solvent hexane and acetone. For blank preparation, hexane was transferred into a microcentrifuge, dried with anhydrous sodium sulfate, centrifuged, and analyzed using GCMS. Sample preparation involved extracting the sample with hexane, vortex mixing, sonication, drying with sodium sulfate, centrifuging, and GCMS analysis. The table presents data on peak numbers, retention time, peak areas, match factors, reverse match factors, and compound names. Each peak represents a detected compound which may appear multiple times. For example, dodecane peaked twice in the GCMS analysis. An unknown compound also peaked 4 times. Retention time indicates the time between injection and detection, influenced by boiling points, column temperature, gas flow rate, and column length. The peak areas represent the amount of specific analytes present, measured in volts minute. Methyl jasmonate had the highest peak area of 49,428,489.79 volts minute, followed by diethyl phthalate and an unknown compound. Match factors greater than 900 indicate excellent matches, while reverse match factors measure ion differences. The average match factor for the sample was 843.54.
The figure depicts a graphical representation of Table 6. Black chromatography results have been subtracted to isolate sample compounds. The x-axis shows retention time in minutes, indicating the time taken for compound detection. The y-axis represents peak area or concentration measured by machine counts over time. Specific analyte amounts are detailed in Table 6.
Figure 2 displays the total ion chromatogram of the blank. Hexane was placed in a microcentrifuge tube and mixed with anhydrous sodium sulfate to remove water. The mixture was then centrifuged at 12,000 rotations per minute for 5 minutes before analysis using GCMS. Blank sampling, particularly calibration blank sampling, is essential to ensure no interferences in the analytical signal. This helps confirm the absence of factors from the solvent that could affect accurate results, hence the blank chromatography.
In total, there are 57 detected peaks in the testing. Based on the findings, the most abundant compound is not a harmful chemical. In fact, methyl jasmonate helps in plant physiology as well as human stress relief according to published literature.
We are ready to entertain your questions, clarifications, and to hear about your recommendations.
Once again, this has been Group 2 with Hydrogaria, profiling volatile organic compounds through GCMS testing in perfumes using alternatives Fragaria ananassa, strawberry hydrosol, and Cocos nucifera